This is Mr. Sandell bringing you a homework solution for Algebra 2. And the first problem we're having an absolute value equation. We need to isolate the absolute value, meaning that 6 and negative 1 needs to go. Reverse PEMDAS reveals that negative 1 is the first step that we need to add to both sides. I think I'm going to go ahead and just say it out loud and then do it so I can go faster. Adding 1 to both sides gives us 6 times the absolute value of negative 9b plus 7, and absolute value is equal to 42 after adding 1 to both sides. Next, we're going to get rid of the 6. The 6 has no sign in between, so we assume it's being multiplied. Undoing the multiplication is division. Dividing both sides by 6 leaves behind just the absolute value of negative 9b plus 7 is equal to 42 divided by 6 is 7. And then from there, we're going to drop the absolute value and turn into two different equations. The first equation is negative 9b plus 7 is equal to 7. The other equation is negative 9b plus 7 is equal to negative 7. From here, we solve them all the same way, subtracting 7 on all of the sides. Leaves behind a negative 9b is equal to 0 and a negative 9b, which is equal to negative 14. And then we're going to divide everything by negative 9. So divide by negative 9, divide by negative 9, etc., etc. When we do that, we're left behind with a b is equal to 0, or a b is equal to a positive, because a negative divided by a negative is a positive, 14 ninths. 14 ninths. And then we can box our two answers. Let's see if we got it right. 0 and 14 ninths. That's weird. 0 and 14 ninths looks like we got the correct answer. Let's move on to number 2. Number 2 is down here. All right, so we're going to solve this inequality and graph its solution. I'm noticing I need to distribute the 3, and that's going to give us a 6 plus 24m. Negative 5 being distributed gives us a positive 25m plus 10. I need to get the m's on the same side, so let's go ahead and put them on the right side. So I'm going to say subtract 24m, subtract 24m. That means the right side is going to store the m's. That means the left side needs to store the constants. So the 10 needs to be moved. So minus 10, minus 10. I have a negative 4, you're gone, is less than or equal to m. Cool. And then I usually like the variable on the left, so I'll put the variable on the left, number on the right. If I switch the sides, I need to switch the sign. So m is greater than or equal to negative 4. Greater than or equal to is a solid circle as opposed to an open circle. Greater than means we're everything to the right. So there we go. Everything to the right of negative 4 with a closed circle. Everything to the right of negative 4 with a closed circle. Nice. Number 3, absolute value with an inequality. That was today's lesson. This is where I want to slow down because some students had missed this today. Whenever we have an absolute value symbol, we need to isolate it, which has already been done. Number 4, we actually have to do a little bit more work. In this case, we just drop it. We say, okay, 9 plus x is going to be greater than 7. Again, all we did was we dropped the absolute value, right? And then from there, we do a second equation, right? We say that 9 plus x, and then everything that's not outside of the absolute, or everything that is outside the absolute value, namely this greater than and that 7 gets multiplied by negative 1, and we flip the inequality, and we say that it's a negative 7. Again, the reason behind this, let's go ahead and say that this is actually Mr. Sandell. This is saying that Sandell's distance is greater than 7 from 0. So here's 0. Greater than 7 means I am either here or beyond, or I'm also over here at positive 7 and beyond. This is saying that my distance from 7, or my distance from 0 is greater than 7. That's kind of the rationale behind these. If you're still confused, we can talk about it more in class. From here we solve, we subtract 9, subtract 9, subtract 9, subtract 9. 9s are gone, leave behind x is greater than a negative 2, and x is less than negative 16. So if x is greater than negative 2, we say that we have a open point at 2 to the right. I don't know, my pencil is not working right there. And then if we are less than negative 16, that's going to be an open point at 16 going to the left. Let's see, negative 16 and negative 2 on the outside. Looks like we have a negative 16 and probably a 2 going on the outside. Very nice. And then last question is number 4. This is kind of the hardest type of question. We did a few of these in class today just to get the hang of them. The general idea, again, is absolute value needs to be isolated, meaning I have to get rid of the 3 and then the negative 3. Remember that there's a multiplication symbol in between here, which means I have to get rid of this 3 first. If I subtract 3 on both sides, I get negative 3 times the absolute value of 4a minus 4, and absolute value is less than, okay, well, I subtracted 3, so subtracting 3 makes us a negative 108. And then from there, I need to get rid of the negative 3. I'm going to divide both sides by negative 3. When I do that, I'm left with just 4a minus 4 in an absolute value symbol. Okay, whenever we multiply or divide by a negative, this symbol does switch. Now it is a greater than symbol, and because I've divided a negative by a negative, I have a positive down here. And 108 divided by 3, I don't really know, but I know it's close to 90 divided by 3, which is a nice number. And then I have another 18 divided by 3, because 90 plus 18 is 108. 90 divided by 3 is 30. I was going to write 30, but I'm just going to write 30 like that. And then it's a number. 18 divided by 3 is 6, so it's going to be 36. This is how I think about it in my head. I can get 36 out loud and make me look like I'm really smart, but this is really what I'm doing here. And then from here, I'm going to drop the absolute value symbol and turn it into two different inequalities. First, I have 4a minus 4 is greater than 36, and my other one is going to be 4a minus 4 is less than a negative 36. And then I solve them all the same way, plus 4, plus 4, plus 4, plus 4. So I get 4a is greater than 40, and I get 4a is less than negative 32. From there, we divide by 4, divide by 4, divide by 4, divide by 4. We get a is greater than 10, and a is less than negative 8. So greater than 10 is an open point at 10 going to the right. Less than negative 8 is an open point at negative 8 going to the left. All right, everything, let's see. So negative 8 and 10 going to the outside. Negative 8 and 10 going to the outside. Looks like we got it right. Cool. Well, that concludes our homework solutions. Thanks for watching. I'll see you guys later.